My name's Patrick McGinley. I'm one of the technical advisors here at MasterSeries. Today we're doing a workshop. The format is a little bit different from our regular webinar. It's more of a training style workshop. I'm going to start the building from scratch all the way through to design. I've created a model for you guys to work with as well. We're working with the MasterFrame module with the wind loading add-on and the finite element and concrete design bundle with the finite elements module and the concrete slab wall design module. This should be the model that you are presented with when you click on the link. So we've got the frame outline, including the nodal supports, all our columns, properties assigned to the columns. We've got 2 slabs already created, so roof slab and a ground floor slab. We've got 3 out of the 4 shear walls included as well, so we can build up 3 FE surfaces there. So we've got our grid lines and our levels defined as well, and then we should have our wind loads and load combinations already applied. I'll be guiding you through the critical stages of creating the FE surfaces and doing the reinforcement design inside the concrete slab and wall design module. Let's create a brand new file. We'll call it FE Concrete Workshop and create. I'm going to start with the multi-story, and that'll help save a little bit of time. So frame preprocessor, I'll select multi-story. I'm going to turn on our member lengths so we can see them on the model space, and then I'm going to actually apply our supports on there as well so we can see those and switch to the front view. So we're looking at 3 spans here, so I'm going to change that to 3 spans, 3 stories. We're going to keep the default span and height the same, and I'm going to change the base fixity to 0. And then if we can preview the changes and then hit apply. Going to now duplicate this frame across 3 times. So I'm going to go copy under the create menu. Again, I'm assuming that you may have some experience within MasterFrame, so I won't go through the interface and all that. There's loads of resources on other YouTube videos and or all our other channels to reference. So we're going to make 2 copies. We're going to put it in the Z direction, 5 meters, and preview those. We're also going to create connecting members as well. So we've got 3 copies there. We're going to apply that. We're going to delete these ground members here now. So I'm just going to go into modify geometry and delete members. I'm going to select that bottom element and preview and apply. So that's our ground beams. We're also going to delete the internals there. I'm going to select those. I'm just window selecting all of those. I'm careful not to select the columns. So if I go into 3D view and hit preview changes, we can see that we're keeping our columns. So I'm going to hit apply. We're going to define ground beams here. So what I'm going to do is going to create, add members general, and we're going to specify a concrete section, and it's going to be 400 wide by 600 deep. I want to get 450 wide, and hit save. And we're going to release the ends, and I'm going to do a bit of a shortcut here. I'm going to turn on the polyline method and then split new physical members at intersection with existing ends. And then I'm going to turn on releases so we can see this getting built up. So I'm just going to click on the 4 corners, and we can see we've generated all those new members in 4 clicks by using the polyline method and split the new physical members at intersection with existing ends. We're going to create grid lines now, and create, add, edit grid lines. Go back to our home view and create grid lines using create multiple grid lines by drawing. So I'm going to click on draw, and we're starting with set 1 in the X axis, and that'll be our numbered grid lines. So if I click on draw and select the base of those columns, and we can set up our grid lines like so. And I'm going to go to set 2, and I'm still in draw mode, so I can click on the columns along there as well. I'm happy enough with that. If I review that in the top view, that's how I want it to look. And now we're going to create levels. So again, create menu, add levels and their global data. So I can just click on generate levels. And yes, level 1, 2, 3, and 4, it has automatically detected the different levels in their Y values. So I'm going to rename that to ground floor, first floor, second floor, and roof. Okay, now we're going to add our FE surfaces. So let's go into add FE surface. So we can access that menu by going into create and add slab wall ramp for FE surfaces. So I will click on that, and we are going to first create our ground floor surface. So ground floor slab, I'm going to rename that, and then I'm going to go to frame views and go on to floor plan. So we can see that I'm going to select add or remove items, and I'm simply going to just window select all those boundary elements, and that confirms that we've got a valid FE surface. So we've got a blue surface in the graphics pane, and then we've got in the preview pane, we've got a black box. If we didn't have that, we wouldn't have our blue surface, and then we would have a red box with a node to highlight where there's a break in the surface. So that's our main border specified. We've got no openings here. Edge support conditions, we're going to be supported by ground beams and nodal supports here. So we don't have to put in any edge support conditions. We can add, if we've got a raft slab, for example, or a ground bearing raft slab, we can put in a full surface area vertical spring support as well. But we're going to go on to our attached beams now. So just to show off the fact that we can attach beams to our FE surface, I'm going to attach these ground beams that we've specified initially here. So at the minute, because they're acting as the FE surface boundary, it's ignoring the properties of these ground beams. But if I say I want to attach those beams, having my add or remove items on, we can include these, and that'll allow us to do the design of those concrete beams as well. So we can go into our material thickness. We are going to select codified materials. Now it's important to have codified materials selected when you are specifying FE surfaces if you're designing them within the concrete slab and wall designer, because that's how the designer speaks to the FE surfaces. If we had user-defined surfaces with, say, layered or ribbed properties, it wouldn't see that. So we need to keep within codified materials. Our material type is going to be concrete. Grade, we'll select C2835. We're going to give it a thickness here of, say, 250 mil. And our loading, we can add a new load to our FE surface. I'm going to turn off 3D so we can see that a little bit better. We're going to add a dead, live, and then a perimeter load here as well. So I'm going to add a new FE surface load. We're going to say that's a dead load. In the Y direction, it's going to be minus 2.5 kilonewtons per meter squared, say. We can add a new live load in the Y direction, say minus 4, and then we can add a new perimeter load. Let's say we've got a masonry wall on the ground floor around the perimeter. We can generate that by saying perimeter line load, a dead load in the Y direction, and let's say something like minus 12. We can see that visually there. We do have the option to put in point loads, line loads, and patch loads, which will require local load points defined if we do want to apply those as well, but we'll not do that now. So we're going to go to our roof and create again an FE surface. We're going to call it roof, and then I'm going to go to frame view and roof plan. Again, we can select all those members. We should only be seeing the roof members there now anyway. With no openings in the roof, edge support conditions, again, it'll be supported by the columns and the shear walls. No attached beams. Material thickness, we can take that slightly smaller because it's going to be less loaded. Add, again, new load, dead in the Y direction, minus 0.5, say, and add a new live load, minus 0.6. Okay, and now, so that's our roof and our ground floor slab. We can do some shear walls here. Add a new group, shear wall 1. I'm going to go to grid line 4 here, and then I'm going to select auto select main border members and add or remove items. Then I'm going to add these 3 panels in the middle. There's no openings. Edge support conditions, we will need to specify a pinned support at the bottom. So we can quickly use the quick set option here for pinned. Click on that and then make sure we are in add or remove items, and we can click on the bottom of the shear wall. And to see that represented, I'm going to go up to their settings here, turn on finite element display options and say label edge releases and continuous supports, so we can see any edge releases or supports that we do define. Attached beams, none material thickness, it's going to copy across the thickness of the surface that we defined previously. So 200, let's say that's 250. Loading, no loading, all the loading that will be applied will be one loading on this frame, so you can keep that full frame. Now what I can do is copy that across. So I'm going to create, copy that and select, pick point to point, and then bring it over to Gridline 1, preview and apply. So that's our shear wall on those two faces. And then I'm going to create a shear wall. If you want to go into your FE surface dashboard, so let's go first of all to frame views, Gridline AA. If we don't have already a new slab defined, we can say add new group and rename that shear wall Gridline A, and we're going to auto select the main border members and add or remove items. So make sure you're in auto select and add or remove items, and then it's a simple case of clicking those three middle panels. You don't have to use auto select. You can manually select your different members that way and enclose your surface using that, but the auto select is rather useful. Openings, we can define an opening here if we like. Maybe I will. So let's say we've got an opening on the first floor. I can right click and add a dummy member, and then I can just say going 2 meters across. I can start, I'll go say 2.5 meters up, add a dummy member again to get that top dummy member. Now we can specify our opening by auto picking our opening. So if you do have an issue there, it's probably to do with some renumbering of members. You can go in, clear the current group, specify your boundaries, come out of check your opening so that it's not including that within the boundary, and then within our openings, then we can specify that this is an opening. So main border openings, edge support conditions. Again, we are going to specify a pin support at the base, and with our add or remove items turned on, we can click on the base, and we have no attached beams. Material thickness, again, that'll automatically update to 250, and no loading. And what I'm going to do, you guys don't have to do it, but I'm going to copy this across to the other side. So create, copy members, and pick point to point, preview and apply. So if I turn on 3D there, I haven't actually specified properties for our columns, and then we're going to use these boundary elements for our first and second floor slabs. So let's go back into our FE surface dashboard. We're going to create a brand new first floor slab. So within our FE surfaces dashboard, we'll go to frame views, planet level 1, and add a new group. And we'll call that first floor slab. And I'm going to window select all these elements. So select outer border members only. I maybe selected some inner members. I'm going to remove that again. And I'm just going to manually select those. So add these. Oh, that's what happened. It automatically selected these openings. So that's our closed boundary there. Going to top view, we're going to create an opening in here as well. So if I right click, add a dummy member, we're going to create it 2 meters across, 3 meters up. Again, add another dummy member, bring that across 2 meters, add another dummy member down 3 meters, and close it off with another 2 meters. So just to recap that, so to create openings or boundaries of openings, we can right click and add a dummy member. It's not so important the dimensions that you get. It's more so just a practice that you can do that within the software to add dummy members for openings. We'll also be adding dummy members for load groups in the next step as well. So it's good if you're familiarized with that. Now we've got our main border specified, our openings, we can auto pick. So we're going to specify that newly created boundary as an opening, and we can review that within the main border tab. And then our edge support conditions, again, we're going to be using our shear walls as supports, so no need to specify any new supports. We can specify releases at the location of those shear walls if we want to. I'm not going to do it here today, but that's also an option. There's no attached beams. Material thickness, we're going to use 250 again. And then now we're going to specify our loading. So I'm going to go back in the top view. So we're going to create 2 loads here. So It's a little bit different from the ground floor and roof slab loadings that we've applied. So we're going to say add a new dead load, dead 1 in the Y direction, and we're going to say minus 2.5 again. We're going to add a live load, and that's going to be part of an alternative pattern loading group. So let's click on add new, and we've got our second load on our load list. We're going to change that to live, and instead of live 1, we're going to say live alternate, and then we're going to specify the alternate pattern load group sets in a separate dashboard. So we're going to say it's minus 4 kilonewtons per meter squared, and then, as I say, we will specify those pattern loadings elsewhere. So if we go into our loads menu and go down to FE surface alternate loading patterns, we'll be brought onto a new menu and set up our load sets. So we need to define load sets for different combinations to design our slab for the worst case. So in this case, we're going to set up 4 load sets. So we're going to define load set 1 as the outer 2 strips in the Z direction, and then load set 2 is going to be the inner strip in the Z direction. Load set 3, we're going to switch it around, and we're going to have the outer 2 strips in the X direction, and then load set 4 is the inner strip in the X direction. So again, we're going to have to specify dummy members along these grid lines just so we can split up our load sets. So right click, add dummy member. I'm going to go from 2D to 2A, do the same again, 3D to 3A, 1C to 4C, 1B to 4B. So we've created our new dummy members there. Then we can set up our load sets. So just make sure that I've got nothing pre-selected here. So I'm going to add these outer strips as load set 1, and then load set 2. I'm going to pan down, and then I can specify load set 2. So load set 1, outer strip, load set 2, inner strip. Load set 3, we're going to go outer strip in the X direction, and load set 4, again, we're going to go inner strip in the X direction. So we can review those by just either toggling or scrolling through them, or else we can view them by turning on our viewing settings along the bottom there. But okay, so that's us set up now for our alternate loading. We don't have to create a new slab. What we're actually going to do is copy this slab up and onto the second floor. So if we go back to our full frame and we have our slab defined there, we're going to say create, copy, add members, and then to bring the first floor slab up to the second floor, we're going to hover over it until it turns into a yellow outline. So ensure we've got our select slabs and wall FE surfaces checked, and hover over, click on the slab we want to copy. It'll turn red. We're going to add a level here. We're only going to have 1 copy, so we're going to pick point to point, or we can say we want to shift it 3.5 in the Y direction, but I'm going to use a pick point to point function and start in the corner and finish in the second corner. I'm going to preview that, and I can see that that's there, and hit apply. Now we can look at it in 3D. Exit out of here. We can look at it in 3D and see that we've got our frame per. Okay. I'm going to generate my own 1 panels here now, so I can manually do that, and I can specify them as 2-way spanning. So that's my 4 1 panels for each of my 4 elevations. Okay, I'm going to assign column properties. So I'm going to go view filters. I'm going to hide my FE surfaces, and then I'm going to go into the property editor and just select all these columns and change those to concrete, square, 350. Turn back on my finite element surfaces again. Okay, so our wind panels have been set up. We want to make sure that our wind is turned on, so I'm going to turn on the master key wind loading and set up my 4 wind directions. I'll do that quickly by just double clicking the angle with X to set up my 4 wind directions. Do it again for the pressure and suction, keep everything else standard, and we'll go back in and we can then set up our site data. I'm going to use a site in Belfast here for Queen's University Belfast, postcode BT71NN, and that'll bring us to the Davy Care building in Belfast if you know it. Okay, that's our site setup, and then I'm going to go in and set up our load cases. And with this, because we get pattern loading, it's not a standard way of setting up your load cases, so I will use the auto generate function. These are some of the presets that I have. You may not see them in your load case generator because I've got a template set up. So if I look at my template, I've got one set up for this particular model. You can also do that by saving any of your templates to file or as a user default. So the way we're going to set it up here now, we need to, for each of the cases where the full slab is going to have a live load applied, we need to apply L1 and L2 so we have the full coverage of the slab, and then we can ignore 3 and 4 until we get to the actual patterning separate load cases. So if we just, I'll go through the automatic load case generator for each of the different load case templates here. So we've got dead plus live, D naught in this case. I think probably the best thing for me to do is to make sure that our density for our self weight is set to D naught just for our live loads only, if we want to do those, because we're not going to include D1 in them. So we're going to change the FE and member density for self weight into D naught, and then back into your load case generator, dead plus live, D naught, D1, D2, and then we've got L1 and L2 in there as well. And we're going to go with ultimate. We're going to keep it to set B equation 6.10 and live only. So D naught, D2, we're keeping D2 in only as because of our load sets. There's no loads applied under D2, but we're keeping it in just to balance things out. If you did have a dead load under D2, you would need to account for that and adjust. So D naught, D2, L1 and L2, so that's our live only, including our self weight. You can rename these within the load group titles if you wanted to for identifying the different loads. Dead only, D naught, D1, D2, fine. Dead plus live, leading. So we've got D naught, D1, D2, and live L1, L2, and then wind as well. But we're specifying live as the leading variable here, and we want to make sure that the factor is consistent across L1 and L2. So we're going to make sure that this group leading, multiple leading variable load groups is selected. Otherwise, you might have L1 with a factor of 1.5 and L2 with a factor of 1.05. So we want to make sure that they're both leading and we've grouped them together. We're going to keep these settings. We're going to turn off that one sign pattern. We're going to keep add equivalent horizontal notional forces, dead plus live, wind, leading. Likewise, we've got the same load groups selected, except in this case, we're having the wind in all directions as the leading live load. Again, we can turn off one sign pattern and then just work through our standard wind loads. Dead plus wind, it's not going to be as critical here because we've got a concrete roof here and it's not going to be as critical for your uplift on the roof, but we can keep that in anyway. And dead plus live pattern 1, so I've created separate pattern templates for each of our dead and live combinations. So D0, D1, D2, L1, and D0, D1, D2, L2, L3, L4. So now we can preview those, scan through to see if they look good. Happy with that, and then replace. So you guys should have those already set up. You should have your 79 load cases. You can review those within your load combinations and look through and see them that way. Okay, so that's our load groups, and then our patterns done. We can set up our FE mesh. We can set up our mesh by going into analysis, FE surface meshing and global meshing options. Okay, by default, we've got the top mesh column to wall region in slabs unchecked, mesh to members inside FE surfaces unchecked, and then our default initial mesh size as 1. So we're going to check the mesh to column wall stiff regions in slabs. So this adjusts the mesh layout to align with our column and wall intersections, taking into account the thickness of your different columns and walls and their profile. We're going to leave mesh to members inside FE surfaces unchecked. You can check it if you want. It makes no real difference. In this case, it might mesh to our internal dummy members. So in that case, we could turn it on, and then default initial mesh size. It's guidance typically is span over 10 or 1 meter, whichever is the lesser. So let's say 0.5 because our span in some cases are 5 meters. So 5 over 10, 0.5. Okay, and then we can generate the FE mesh. We'll generate it now just so we can have a look at it and see it get built up. So that's all our stiff regions being set up first, and then we'll start meshing the frame then. So if I turn off 3D, we can see that, and we can see then, if we look in the top view, the stiff regions for the extents of our columns and shear walls. So those will be ignored in the analysis. So we should be able to analyze this now. So analysis, static analysis, and it'll take a second there to analyze, probably about a minute. So I'm going to have a look at some questions. So are you able to import CAD drawings? Yes, you can import CAD wireframe drawings if you wanted to build your model up externally into MasterSeries, or else you can import CAD drawings as a layer to trace over. So you've got a couple of different options there. Is it possible to form steps and openings in slabs? Yes, you can define openings in the surface, which we defined earlier. And to create a step, you just need to split the FE surface up into two separate surfaces and then assign your different thicknesses accordingly, and then whatever connecting elements you have there. Can we get a copy of the low-case template file? Yes, I'm happy enough to save that up and post it with the rest of the model files and details. Okay, that's analysed for us there. So we can go into our graphical analysis results by going to results on the top menu, clicking on graphical analysis results, and then reviewing. So we can look first at our line elements. So if we look at the graphical analysis output dashboard, we can view line elements and click on, by default, we're given axial. We can show our values there and have a look through for our different load cases. We can change our load cases at the bottom there, and then we can look at our bending moment for the different load cases as well. We can show our values, for example, in the major axis only. We can do the same for torsion, shear force, and deflected shape as well. So you can look at your deflected shape and review that. Quite a good place to start in reviewing your frame. And your nodal deflection values, for example, it'll only give the nodal deflections for the frame as opposed to all your internal FE nodes. But you can look at your nodal deflection values, or your FE surface deflection values as well. So if we go into our shell elements along the top, so I was just in line elements, we're going to go to shell elements to look at all our contours and various outputs related to the FE surfaces. So we can review under forces and displacements our forces, our moments, shear forces, displacements as well. So I can look at the displacement of each of the slab, and then we can turn that on to 3D as well if we want to look at it that way. So another way of viewing our Y displacements, we can see some torsion values and then our required reinforcements, which are based on moments in each direction. So if we wanted to sort of do a preliminary check, we can go into those, specify a cover, design code, for example, Eurocode, steel grade, concrete grade, keep it at 30. And then we can have a look at, let's say we're looking at level 1, S required top and Y direction, bottom, X and Y direction. So we can do a quick review there on the steel required. And again, of course, all of our different moments and shears and values through there. And then we can look at some stresses as well as an option. It's recommended also to check for your maximum error when you do come in here. This gives an indication of mesh quality, numerical stability. So high max error percentage, which is typically above 10%. If I show our contour legend there, we don't go above 4 there. Let me see if I go max value 10%. A high max error percentage of above 10% may point to insufficient mesh reinforcement, particularly near stress concentration like support slab openings or column heads. So we can see we're not too bad there. We're generally within 10% throughout, bar maybe the odd little location there. So we can review those and refine our mesh if required. The other one I want to show you is our section line diagram. So if we want to, in addition to your contour plots, you can use section line diagrams to extract and plot result values along a defined line. So I can quickly show you how that is done. So let's say we want to select a line across the slab, average it out over 1 meter and see how our bending moment is looking there. Maybe scale that up a bit, be able to see, and then show values along that. So if you wanted to get like an average strip, for example, in this case is a 1 meter average strip across a slab, and check it that way, you can do. So quite a useful tool there in your analysis. So as I promised, we're going to jump into the slab design module. So if we go into our design and concrete slab design module, we're introduced to some defaults settings. So that this sets standard design parameters for our automatic slab reinforcement design. So you can specify here some main rebar grades, covers, again, punching shear rebar grade as well. Basic rebar, we're going to use 10s to 20s throughout. You can change that to whatever you think you might want. For example, 16s at 150s, another common one, will work with 10 and 200s in this case. Peak zones, we can say if we want to auto size or peak zone during the auto design, and then say whether we want it over 1 zone or 2 zones. I'm going to change this to 1 zone to simplify it, and we can say we can auto size the peak zone during auto design. So you can play about with that as well. So at this stage, you might be following along. So the only changes we've made is peak zones, auto size the peak zone, or else change the 1 zone or 2 zone. It doesn't really matter. We can always change these settings later in the module. Our strip zones are set to 1 meter from the strip line. That's okay. Orientation is perpendicular to the strip line. Fine. And then auto design bars. So these are the bars we want to specify. So let's say you didn't want to use anything above 20 or below 16, for example, you can remove those. Or if you didn't like particular spacings, you can remove those as well. Detailing settings as well. So we'll save that up. So I'm going to give you a bit of a workflow for the slab reinforcement design. So we've got 4 options here. We've got a basic reinforcement, which we'll set up first. We got a peak reinforcement, typically for column heads, where we've got a lot of hogging moments. Strip reinforcement, we are actually going to specify some of that as well for above our walls. And then punching reinforcement, we can do punching checks within the module as well. So let's set up our basic reinforcement, and we can do that by just adding a new item, and we'll see a new set formed. We're going to have to specify the FE surface that we want to apply to. As you know, there's 8 surfaces in this model. And then, so we're going to click on select and hover over this first floor slab. Again, make sure you're in planet level 1, so we're dealing with the correct slab. And then click on it, and it'll run the check for 10s at 200 throughout this slab. So we can scroll down here and have a look at some of these values. So it's placed within the selected FE surface. We've bottom bar specified 10s at 200 and top bar specified at 10s and 200s as well. So we're getting a failure. We can review those by going to our drawing options at the bottom. So we can look at our forces like we have done previously there in the analysis output, but we're going to be focusing on our unity ratios here today. So the value that we want to draw is, we're going to first look at the bottom reinforcement requirements, and we can look at our sagging maximum values. So let's look at this, and we can see it in both directions. We will need reinforcement. We will need to up the reinforcement, because anything above a unity ratio of 1 is highlighted as orange or red, and we can see that throughout. So let's go to value to draw and change that to sagging in the X direction. So our calculation output on the left is telling us that we have we require more reinforcement, more basic reinforcement, and we can see it as well in the graphical pane. So bottom reinforcement in the X direction, that's in direction 1. So we're going to go up the bottom bars direction 1, and we can change that as well. We can see in the output there that it's a 40% over 40% over there. So if we change that to bar diameter 12s 200 and click on refresh, we can see that our unity ratio now is below 1, or in this case it's actually at 1, but that is giving us a critical value. So if we look at that, if we look on the graphical pane, and we're looking for the bottom in direction 1, we can see up here we're being given an error. So we're given a very, very highly localized peak. So for the purposes of this, we can ignore. So we're happy with that, 12s at 200 in direction 1, i.e. the X direction. And let's go to sagging in the Y direction. And we've got 10s at 200. I'm going to change that again. We're going to go to 12s and refresh that. And already we can see it's passed in the calculation pane. and then we can see where is the most critical area. So it's a maximum moment in the bottom direction 2 is here. So we're well in. We can rename that basic rebar to first floor slab, and then we can look at our top reinforcement then. So go to value to draw, unity hog max, and we should see that we need it in many locations here. So what we can do initially, we'll have to specify peak and strip reinforcement on the top face of the slab, and probably in both directions. So we can just increase the reinforcement to reduce the size of these peaks. I don't think it's probably not wise to specify reinforcement to deal with all of them, because it would be a bit of an over design. So we'll just say up that to 12s in both directions and hit refresh. And as I say, all we're trying to do is really reduce the size of these peaks. So then we can look at each direction as well, X and Y direction, and review it there as well. So to deal with these top unity ratio failures, we're going to assign peak reinforcement. We can either do it individually or we can do it all at the one time. I'm going to say add multiple. So we'll go under peak reinforcement and click add multiple and window select the full frame, and that'll automatically create peak zones specified. I think they're 1 meter default peak zones throughout, and that'll just cover the zone. We can do an automatic design and that'll cover the extents of the area that we need it, and then you have to specify your own laps, etc. So what we can do is keep those in there and then do our check on each individual peak zone. So if we look at peak zone 1, so that will be for corner column. Let's select, turn off add multiple mode and just select one of these internal columns and review, so we can see that we've already got a failure there. What we can do is multi-select all our 4 internal columns. We can give it a name, internal column. If it doesn't specify which internal column we're on about in the design output, but we can rationalize later. So we have got, what have we got? Bar sizes and bar spacings. They're different for each of these. For our internal columns, we can say we want our bar spacings to be 200 mil to follow the parent FE surface. We can auto size the zone. We can tell auto design to auto size the zone that we're working on. And then the bars, we're going to specify those as designed automatically. And once selected, we can click on under the auto design, do auto design and click on selected, and that'll work through and resize these and specify the reinforcement required. Now, under drawing options, we can click on draw related basic areas and then click on refresh, and we can check the max value on that for those inner zones, and we can see that we're not getting any failures at these locations. And then we can do the same, for example, for our corner columns. I'm getting a few questions coming in here, so I'm going to have a look at those in a second. So those corner columns, again, we can, if we want to group those naming wise, we can specify those as corner columns. And again, if we want to say we want to keep our bar spacings at 200 and auto size the zone, we can do that and then click on do an auto design on the selected, and again that'll provide us with a dimension for our different columns. So if I just select one of these individual, so corner column, we can look at that one and then see what has been specified. So we've got 16s at 200 at a half width of 0.55, so it's actually coming in 275 mil either side. We can size them to however we want. If we wanted to keep them all the same size, we could have a look through and see what dimensions they are. That's for our corner columns, for example. We can look at our shear wall peaks, highlight those here, wall ends, and again we can do our auto design based on 200 mil bar spacings and selected. So now we can review all of the reinforcement that we have specified. So let's go into our drawing options, and under rebar areas we can turn that on, and then we can say rebar to draw, bottom direction in both direction, and then top direction. We can see that we've got in these locations, green is 12s at 200 T1 plus our basic reinforcement, and then our green there is our turquoise is 16s at 200, and top direction 2, and we've got 12s at 200 there. as well included. So we can do a review on just our peak, or we can go into our basic as well and do a total review on the on all of our reinforcement. We're going to add strip as well, but you can have a look through your reinforcement at this stage. It's very likely you'll want to rationalize those different peak zones as well. So let's check our hogging at the location of our shear walls again and hit refresh, and we'll need strip reinforcement at these locations. So the way we can apply that is by clicking on strip reinforcement. Let's add one and we can copy that across. So we're going to add by clicking on the add new item button. Our strip zone will be set up. We need to define the parent FE surface. So we'll click on the parent FE surface and then we can place it by drawing. So we're going to draw a strip line start and end, and we're going to do that. We're not going to do it within the boundaries of the existing peak reinforcement, because where they clash will not actually double up. We'll take the peak reinforcement over the strip reinforcement. So we'll define the strip reinforcement outside the extents of our peaks. And okay, so that strip zone, it adds to our basic rebar. Our auto design settings, we'll maybe keep that to 200 as well. The bar is orientated perpendicular to the strip line, so we went top to bottom on the strip line, so our bars are going in the direction we wanted to. In the top face, the cover is set by default. The bars are 10s at 200, and we are being given a slight warning, so we could up that to 12s manually, or we could do an auto design, which I'm sure would do the same. And then some other details there. As I said, we've got the geometry there. We can manually change the geometry by stretching it out or stretching it in, and we'll probably need to take it out about a meter or so. Now we've got that defined, we're happy with it. We can copy that across, and it's as simple as just setting the parent slab again, drawing that in, and it'll bring in all the same reinforcement details, and we'll do that another 2 times. So let's refresh our unity ratios for the top of the slab, and we can see there that we're looking a bit better. So we've got, upon review of our calculation, we've got errors in the top and bottom direction, top direction 2, bottom direction 1, but they're ever so slightly out. And if we turn off those values and zoom in on where we're getting our errors, they're going to be very localized and not critical. So we can be, let me see if we can find them. Yeah, ever so small zones there, which you could extend the area of your peak reinforcement just to cover that. And X direction. And then I think I've seen another one. Okay, but I think you get the idea of how to work your different reinforcement types. So I'm going to take a second here and look at the questions before we get into our punching. Can FE analysis be used for rib slabs? Yes, you can specify isotropic, orthotropic, layered, and even rib FE surfaces in MasterSeries. Although with those types of slabs, you won't be able to do your slab design with the slab design module. Can FE analysis be used to design RC shear wall reinforcement? Yes, we can design shear walls as well. I can show you that. Curved shear walls, you can model curved shear walls in slabs, but you're going to have to split it up into different FE segments, surface segments. I'm not too sure what you would require that for, Stephen, if you wanted to elaborate. And does the auto design peak zones ensure sufficient bar laps are achieved? No, the bar laps will have to be specified beyond what you have in the slab reinforcement design. So it'll only cover the peaks, and then beyond that you'll need to specify the laps. And then what is the process to get the reinforcing to reinforcing layouts and bending schedules? So the concrete column, beam and pad modules all do bar schedules, but the concrete slab and wall designer will produce design intent drawings as opposed to detailed bar scheduling drawings. But we can have a wee look at that as well if we've got time. So I'll just jump on to had the question about the punching shear checks. So we can very easily again carry out punching shear checks for all of the columns here. So if we click on add multiple mode under our slab reinforcement punching, we can multi-select all these nodes. We can then pan through and check our different punching shear checks for each of our different nodes, either manually by making sure we've got multiple mode turned off, or else by clicking through the list. Now I'm going to go on the 3D here, and I'm going to highlight there. We've got our FE surfaces. We've got our punch and shear checks on our shear wall ends, which use the FE shear forces design force method. It's recommended to have that for all of your punch and shear checks when you're getting your values from your FE surface. So I'm going to change the corner columns and the internal columns to use the FE shear forces method. So again, taking our shear forces from the surface analysis rather than just Eurocode values or factors. There's options there for how your shear bar layout can be set up. So for example, if I click here, we can say equally spaced on perimeter, radial layout, even grid, or cruciform from support face. So you can play about with those settings. But the key thing here is to highlight the fact that the punch and shear checks can be done within the software. From experience, you used to use spreadsheets to check punch and shear checks outside of the FE software in the past. So it's great now that it can be included in your slab checks. So we're going to go into the design menu here, go to concrete wall design. And again, we've got some defaults for our grades and cover. Our wall piers, so the wall piers, we're going to set up 16 to 200 as our default rebar. Our design methodology is the key part here. We'll use the equal strip widths method with a standard 1 meter strip width, which is ideal for regular pier layouts. And then again, we can set up our preferred bars and spacing there. Wall coupler beams, we get some settings there for whether you use a strut and tie method or deep beam method. There, we're going to keep that as default, and the bar sizes and spacings. Okay, so we'll save that. We'll go into our full frame view and can create a new wall pier zone. So we can do that by adding a new item and selecting the surface that we want to apply our wall panel check to. So this is wall pier zone 1. We're going to place it by drawing a rectangle, and we're going to go from the bottom corner to the top corner, and then that'll automatically create our wall pier zone check and specify our reinforcement. So 16 to 200 vertically and 10 to 200 horizontally. I'm going to turn off our FE mesh so we can see that a bit better. So under our drawing options, we're going to turn on draw, and under the critical load case forces, we can toggle between axial forces, shear in our major, minor, and then moments in our major and minor as well. So we zoom in to there, we can adjust the scale to look at those values, and all the values will be associated with it if we turn it on, and then we can go through those. And then if we wanted to, we could do an auto design on that similarly to we have done in the other reinforcement panels. So in this case, we got a failure, so we can manually manage that and say that we want, let's say we want to keep it back to, maybe we should specify our bar spacings that we want to stick to. But so this has come up with 12s at 400. I'm going to keep that at, say, 12s at 200 horizontal bars, 10s at 200. So we can set all those up to stay within defaults that we wanted to. I didn't think that I've got that set up. Okay, so probably a good idea to set that up initially. This is restrained in the top and bottom. We can change those restraint conditions. So that's one panel setup. If we wanted to add a new panel, we can do that, add a new item, and again, select our surface. And then we're going to be setting up a pier here. So we've got an opening here now. We're going to have a coupler beam on top of this. So we will need to specify our opening to our pier to the bottom left to the top right. And we can see that being generated. And in the same fashion, you can edit your reinforcement and restraint conditions. But what I'm going to do is use the auto generate zones functions to be able to set up all these wall piers and our coupler beams. So if we manually want to check a coupler beam, which is for the openings above the doors, say, we can add that, draw a rectangle, make sure we've got our parent slab selected, and then again do our coupler beam check and do an auto design on that if we want to, and that'll give us our reinforcement for that deep beam or however it is designed. Let's see, yeah, so it's using standard beam theory as opposed to strut and tie. Again, if we want to auto generate all of these, I'm going to take these out, just delete these as they're set up. Click on auto generate zones. So this will automatically allow us to set up our piers and our coupler beams without us having to manually do it for each. So we're going to say we want it done for all of these 4 surfaces. So auto generate zones. Once our options come up, we can say that we want to split our piers at defined levels and connected slabs. And then we want to auto-generate our coupler beam design zones based on our minimum span to depth ratios. So now I'm going to select all of our shear wall surfaces and click generate, and you'll see automatically all our piers and coupler zones are being set up. So let that generate now and we can review. So if I go into my pier zones, I can pan through and review, and likewise for coupler beams, then it's automatically detected that there's a couple of openings in there, and it's going to do our checks on that. So again, we can do an auto design based on the spacing and reinforcement that we want to use for that. There's obviously options to output all of your reinforced design, so we can generate it as a report into Word, and you'll see it being built up there as we can see. So I'm going to take that, put it in the background, and then we can export that to our DXF or DWG as rebar intent drawings as well. As I mentioned earlier, we won't get bending schedules or bar schedules based on the output here, but hopefully I've given you a bit of an overview on how to use it. I'm going to go to the questions here now again and see if there's been any new ones. Can we solve FE surfaces for long-term deflection and crack analysis? Yes, we have another module for that. I'm going to direct you to a webinar that we've done in the past. It's probably the most in-depth content that we have on this. So if I go to, our lead developer, Martin O'Gara, has provided this webinar specifically on long-term deflection and crack analysis for FE slabs. So that is a module available within MasterSeries. We can access the concrete slab deflection and cracking module through the design menu as well. And then that is included as part of the FE module. So there it is, concrete slab deflection and crack control. So I can give you an idea of how that looks. And as I say, it's part of the concrete slab and wall design module. So it's an add-on. In reference, if someone wants to get deep in the theory behind the slab and wall design module, yes, our manual is probably the best place to look. Our manual is quite good, and if you want to do a deep dive on the slab design and read through about all the different options within the design methodology for the module and all our different checks, you can do that within the manual. And there's more information on the slab deflection and crack controls in here. So that's for the slab, and then your wall design as well. You can get into the details on the design workflow and methodology in there as well. So today we covered MasterFrame, setting up our frame in MasterFrame. We've applied some unloading. We actually touched on the Office tools there, our Microsoft Office integration. And then we built up our 8 surfaces within the MasterFrame finite elements module, and then we carried out the design of the concrete slabs and walls within the associated modules. There's deflection and cracking, as was highlighted as well, that can be checked as an addition to these modules, but the one module will get you both slabs, walls, and also again the deflection and cracking module. So these come as part of either the power pad with an upgrade, so you can get the power pad with the finite element surfaces up to 200 meters squared, and then you can go for an upgrade as well with the concrete slab and wall design module on your power pad. You can get them as part of your full building design suite. So the finite elements comes as standard with your building design suite, along with unlimited MasterFrame members and your wind loading, your BIM integration as well. That all comes part of the core bundle. And then if you wanted to add your concrete slab and walls, you would opt for the concrete design bundle upgrade, which is option 3 there. And you'll also get your beams, columns, and pads included with that, alongside your pile cap design, which would be useful in the frame we just looked at, because we do have concrete beams, columns, and we have to manage a substructure somehow, whether it's through maybe pads or pile caps If you're not a MasterSeries customer, you can also get these on a perpetual license as well. So just get in contact with us about that if you are interested. Otherwise, if you've got any other technical or sales inquiries, give me a shout, or Andrash, who's helping here today as well. And yeah, we can get caught up at another stage. Okay, thanks for your time today. Sorry we went quite over. I thought it might take a bit longer. I didn't suspect it would take so long, but there was a lot to cover there, and hopefully you're a bit better off in approaching your concrete frame analysis and design within MasterSeries. And I will catch up with you guys on the next one. Thank you.